Hey, how's it going? Finally, hey, SAQ 3000, good to see ya. I'm back for a bit here. Just did some zooms, and we're back here for a bit just to get some more C coding going. We're gonna do some C basics. I'm really excited about this. See if we can figure out and remember some things that we haven't typed on the keyboard for a while. Kind of neat. Also, SAQ 2000, you had another Mandela effect. I kind of want to see what you were, remember what I needed to show you? Yep, the Mandela effect, yeah. I wanted to, let's check it out. We can check it out. We got time now. We have time. Let me check. I want to make sure what we are. Let's see here, clickety buttons. I want to make sure I'm ready because I got another Zoom headed up here. Okay. All right. So we got about an hour, so we should be good. We should be good. About 1 hour. Oh, it's this. All right, nice. I'm kind of curious. I'm see if the Mandela effect. Let's see if I'm part of the prop. Let's see if I'm part of it. I'm not part of it. All right, so let's get rid of. All right, so let's see here. There's a lot of Okay, let's clean some stuff up. Actually, you know what? What we could do is. Hold on. I want to see this. See this line right here? This line right here, line 45? This compiles. This compiles, and it runs. Why? What I want to know is why. This right here. So I'm not familiar with this syntax. Usually, when you put two variables side by side, is there some sort of operator? Hey, HH94207, it does not compile for you. Oh, does it not? It might be... This isn't... You came right in with that. That's actually really neat. I was not expecting that. You came right in. See, let's see. Oh, whoa. Whoa. Hey, it doesn't compile for me either. What happened? What happened? It's different. All right, so wait. All of a sudden, errors happened. Okay, so Torva pasted this as a result, and so I was like, this seems like it doesn't work. And it turns out it doesn't. It turns out it does not. All right, let's check again. Okay. Let's say, hey, C today. Yep, Summit. We're doing some C today. We're doing some C. Done with the stand-up? Exactly. Yeah, exactly. You know what it's about. You know what's happening. We're back again. We're back at it. All right. So I want to see if we can make Torva's function compile and work really quick. Let's see if it compiles and works. All right. So should not return a value. Okay. Because we have to... How do we do this? Do we say void star? Then we have to do void star, and then Torva's function will start working better. Yep, there it goes. There it goes. All right. All right, now we're at it. Okay. That's better. Okay, so what if we got rid of this? C today. We're doing C. There is also an error with the return type. Yep, you're sending the point. Yep, exactly. Yep, right here. Right on top of it. Right on top of it. You got to put a little star symbol right there because it's returning a pointer. Boy, a pointer. How old are you, bro? Karmu? Over 40. We're over 40. Are you familiar with Primogen? A little bit older than the Primogen. Steven, did you see your message? I did not. Oh, there it is. I see it now. Do you remember Breaking Bad character? Yes, Jesse. What did he say? Yes, science or science B-I-T. Yep. Science. Yep. He used the curse word, right? Didn't he use, he used the profane version of what you're describing, right? I'm pretty sure. And am I part of the 40 plus? I know, not possible, Karma. I know. I know. It's crazy how fast time flies, isn't it? It's crazy how fast time. You look 20, 22, 3 years old. No. Well, it's because I stay inside. I play on the computer, and I eat healthy. Healthy, like vegetables, right? You got to eat those vegetables. And it turns out it's worth it. It's worth it, you guys. You got to eat those vegetables. All right. So I want to see. Did this not compile? Oh, so then that means that. So there are two. Well, this might not be Torva's fault. Okay. So I think what happened was copying from Discord. The stars, yep, the stars got converted into, so Torva, what happened is you did have it was correct. It's just that when you pasted it in the Discord, you needed to put it into a code block. because it took the star symbols, like it was doing this, right? So it's like italics and 2 stars, and it turned it into italics. Hey, thank you for the likes, you guys. Thank you for the floaty heart icons. Thank you, thank you. Steven, that's it. Everyone remembers it as the check yourself on YouTube, please. Really? I thought it was the profane version. Thank you for the reactions, you guys. Appreciate it. See the little floaty heart poppy party poppers. Got the party poppers there. Okay, so Torva, yes, Torva, it's fine. Your code was fine. It's just that you got to put it in a code block, so that way it doesn't take all those star symbols and turn into italics. Italics. This streamer is okay. All right. Thank you for the hearts, you guys. Appreciate it. Okay, so let's see here. Now that we did Torva's task, let's see if we can do a few more things. So let's do some strings. We'll do some structs. So maybe static var. Try the static var. Please do it on Python. Sure. Sure. At some point we'll get back to Python. Today we're doing C. We're doing C today. We will go back to Python. Python is a more widely used language. C is not used that much anymore, right? Although it is powering most of the internet still. It's still all the routers and the software operating the routers. It's still C, you guys. It's still C. SAQ 3000, I'll have to check that out later. Hello, Steven. Alp Arda Yalman. How's it going? Good to see ya. We're doing some C coding today. We're just doing some of the basics. A little bit earlier today, Torva, who's on YouTube, recommended that we try building our own calc function. And I wrote a calc function here. And it was pretty close to the recommended calc function that Torva wrote. You don't seem surprised. I want to know something new. 2012, the world did end and explode, but we're alive. Surprised? Well, yeah, now I am. A little bit surprised. What are your other hobbies other than coding? Like playing video games. We're almost done with Silk Song. We got to Act 3. When it's basically hard mode at that point. It's hard mode. And we're right at the very end of Act 3. I'm pretty sure we're going to beat the game the way it was, the ultimate beating of the game. Also, Final Fantasy Tactics. I've been playing Final Fantasy Tactics. And then go outside. I don't know if you can count that. GTA, yeah, Karma. I love GTA. I'm really excited. I played GTA 3 and 4 and 5. What is the new GTA that's coming out? What's the new GTA, right? Is GTA 6? That's the new one, right? Are we ready for GTA 6? It's supposed to come out this year, isn't it? Like late this year, probably. I'm really excited for it. I want to play it. When GTA 6 comes out, definitely gonna get that. All right, let's double check this. Main. Oh, looks good. And so I want to double check this really quick. Save, right? And then it should fail. Yeah, okay. Got it. Works good. Okay. I was like, I didn't think that was I thought that was a problem right there. All right. So we got rid of, actually, you know what? Let's make a new file. So let's make a new file. Why don't you build GTA 6 yourself, bro? Well, they spent a few $1 billion on making the game, didn't they? So I can't quite make it myself. I just can't make it myself. GTA 6, not this year though. No, I want it. It's okay. I'll wait. Okay. ls mv main.c to old main.c. Okay. Actually, let's do cp old to main. There we go. Okay. Reopen. Disable Copilot. Okay. Resize. Pane. Resize pane. 10? Wait, I forgot how to do this. I'm trying to do that. Can you hack Hey, Steve 12! Welcome on in! Always in with the hack questions. Can you hack GTA 6? Well, wasn't part of the code base already sort of released unintentionally? Someone got access to it and they're like, we're gonna release some of your code base, and they released some of it. All right, let's see here. Tmux. No. Resize. Yeah, resize, pane, and then how do we do this? I forgot. Unbind down. Wait, increase? No, I forgot how to do this. Thank you for the party poppers, you guys. Do you guys remember how to? I don't do this very often. Change the size of your Tmux window. Do you get eye strain from prolonged screen time? Yeah, though it needs to be a really long amount of screen time, like more than 10 or 12 hours. Then you get some eye strain. Otherwise, that's fine. Finally, happy to see you. Chitter Royal, good to see you. Happy Monday. Thank you for joining. Thank you for the party poppers, you guys. How's life? Yours is good. .gf, fine.gf, nice. I like that. Fine.gif, you guys. Got the animated photograph. All right, so Tmux, shrink, window, pane. I forgot to do this. Let's just look this up really quick. Pane, is it -L? It says -L10. Nope, that didn't work. Pane resize. How do we do this here? Blur, blur, blur. Up, shrink, left. Oh, ref, up and down. Okay, so I got to do -D. 10. There we go. That's what I'm looking for. All right, so that gives us a little bit bigger there. Nice. Okay. Have you ever gotten red, dry eyes? Not once, maybe. Once. Maybe once. A long time ago. A long time ago. All right, so now we've got a new, let's delete all this code because we got it somewhere else. All right, what we should also do is we should make a little GitHub repo of this. Get init, get status. Actually, we should mv old to calloc.c is what we should do. Okay, rm main, get add status. All right, git commit. C basics, and then we'll make a new Git repo. GitHub, new repository. Click the plus button. New repository. Here we go. All right. We'll call it C-basics. Steven. On stream C basics. Live coding. Public. Perfect. Perfect. Looks like you manage your screen time, work, and sleep very well, bro. Very nice. Karma, well, somewhat. Like a little bit. I think it's more just you get like used to it. After a few years and you practice enough, you can kind of get used to it. Just joined. Hey, Sammy Marcos. What are we coding today? Today we're going to be going over if you've coding in C, just the C language, or if you remember coding in C from previous times, which is what I'm doing right now. We're going to refresh our C basics. Obviously today you do not necessarily want to write C anymore. C is old, although it's still one of the fastest languages, obviously, unless you jump down into the assembly layer and you target a very specific architecture or specific processor, right? With C, it's like a portable language, portable, where it can be compiled into specific assembly targets for your architecture. Now, what we're going to do is we're just going to revise some of our experience that we had with C, just going back over the basics. Some strings, pointers, functions. Did you know you could do a function pointer? We should do a function pointer. Oh, we should add that to the list. Let's add that to the list. Okay, where's that at? There we go. We'll add that to the list. We should do function pointers, you guys. We should do function pointers. For callbacks. All right. Function pointers for callbacks. We should do that right there. Function pointers for callbacks. Pointers. There we go. I learned computer science first course in C. That was 1999. Nice. Yeah, I did in the 90s. I also C++ was my first language. Probably a mistake, right? C++ is a little more, C is probably a little bit better of a choice as your first language if you have to pick between the two. So I chose C++ and I had a hard time. Although we're doing good now. It is definitely a few years later, beyond the 90s. Okay, function pointers, we should do that. I really want to do that. We'll get that back up there. Let's see here. Let's grab this. Push there. Okay. Git push. Main. We already pushed, so we should be all up to date. All right, good. Okay. All right. Now, overwhelmed calmness. Overwhelmed calmness. Let's see here. All right. Let's get back into it. I'm actually really excited about function pointers. Have you done this in C? I bet you haven't. I feel like you might not have ever done a function pointer for callbacks in C. Maybe you have. I don't know. It does require a little bit of extra syntax. I think just a smidge more syntax. Okay. So we did some things. Let me see here. I'm just going to get rid of a few things here. Did some prints. Get rid of that. We don't need that. Don't need that anymore. We're gone. I got a sig fault while writing hello world in C. That is a good job. If you did that, writing a hello world, a sig fault, that is kind of hard. That you have to go out of your way. You have to go out of your way to do a sig fault in C when you're doing a hello world. Obviously, a sig fault is very common in C. Don't get me wrong. It is. You run into this situation quite often. However, to do that with a hello world is a whole other thing. It's a whole other thing. Okay. Okay, so these are all the things that we would like to do here. Let's start off with strings first. All right, let's get this going. Okay, so we can int main. You want to return 0. You don't have to, obviously, because it works without it perfectly fine. We've got some headers up here for standard input output, standard lib, which gives us access to like mallocs and stuff. And then you've got string, which will give us access to memset. You tried writing without this studio IO lib? Oh, stdio. Standard IO. Ooh. Can you do that? How would you print? How would you print in C? Can you do that? Actually, here, constui. Can you do that? Can you print anything to the terminal or the output for the application without this library? How to write assembly? Yeah, okay. Okay, got it. Yeah. Understood. And then you're just calling, system calls. You're doing system calls directly. So, sure. Yeah, okay. That's fine. I got it. Okay, so basically, yes, you can, although you have to write it in assembly, not directly in C. All right, so I want to try dealing with strings. Let's do strings first, and then we'll get some function pointers. Thank you for the reactions there, you guys. Got to do some reactions. Thank you. All right, so let's do char. We'll say name, and then we'll say equals, and I think we can do this, right? We can straight up do this because it's a static char, right? It's essentially static. And we'll do constui. All right, we got constui there. And then we want to, let's see if we can print that. Print, print, f, and we'll go %s, hello, %s, exclamation point, and we'll say name. Okay, that should print hello constui. I'm pretty sure. Let's see if we can make it happen. All right, let's see. clang main.c-o main, and then we'll do and ./main. All right, there we go. Hello constui. All right, there we go. We were doing some basics. Now we're into it. Some of the basics. Okay. How can we dynamically allocate some memory? Char star dynamic name equals malloc. We do a char. Can we do char? Char times, we'll just say 10. And then we will, we need to print into it. Hey, just a random learner. Good night, brother. Before I sleep, did you discuss Marco in C? What is Marco? Are you talking about macro? Oh, macro. Macros. Yeah, I thought it was like Marco. Macros, yes. All right, we should also add that on the list. Macros. Macros. Right, you got to add macros in there. Got to add the macros. Thank you, Just a Random Learner. Good idea. Good idea. I haven't frequently used macros that I wrote myself. I haven't frequently used that. Usually I just write the code straight into a function and off to the races. However, macros, you could do macros. Let's add those to the list for the hello world. Okay. So, what else do we got? Chart, pointer chart. How do we now populate? Function F2. Printf. All right, Kunstui. Stefan with the misspelled, right? You got the A instead of an E at the end, right? Stephen or Stevan. Stephen or Stevan. All right, name or Stephen. Oh, name Stephen. How about this? Name Stephen equals Stephen. It's got an E-N. E-N. You almost got it right, Kunstui. You almost got it right. Let's see. We'll comment this out here real quick. Hello, name Stephen. There we go. Stephanie. I know, right? It's really close. It's really close. They're not far off. They're not far off. All right, let's see if we can build that. All right. Oh, we got to put a new line character. Let's forget the new line characters there. There we go. All right, Kunstui and Steven. Also, we should probably we should also add in, right? We'll add an SAQ, right? SAQ dash 3000. Stephanie. Stephanie, no. Okay. Make sure that's all nice and written. Run. All right. There we go. We got some names on the screen there. We got some names. All right. What I'd like to do is figure out how do we do this dynamic name. Let's see if we can do that. And then it's called scanf. Dyname. I forgot how to do that. And that will ask the user to input some name. And we can do Sam the Ham. Hello, what are we doing today? Sam the Ham? All right, well, let's see if we can get it working, Sam the Ham. Scanf. Oh, wait. Format string is not string literal. Better. Let's see here. We'll figure out. Oh, do we have to do like a size? Size of? Yay, all right, we're getting better now. All right, let's do this. Stevenson, all right, steps. All right, we got it. All right, Sam the Ham, we're writing in C. We're doing C basics today. And I'm going to change this window, right? Resize, pane, and I want to say dash U. We'll do 20. Oh, that's too much. All right, we'll get. How about dash D20? No, that's not enough. Okay, we're D30. No, okay, wrong direction. U30. It's way too much. All right. U or D10. All right, we'll do. Okay, perfect. Okay, rebuild. Okay, there we go. Okay, format string is not a string literal, potentially insecure warning. Warning, you guys, it's a warning, and is it going to work? Well, let's see here. Scanf. This didn't. How do we grab? In C, do you guys remember how to grab user input from the terminal window? Get user input from terminal window. C. How do we capture that? How do we request that? There's scanf, which we tried. We tried just now. Kumar, scanf. Yep, we got scanf right here on screen. We got scanf. Kumar, thank you for subscribing. Welcome on in. This channel is all about software engineering. We do coding by scratch. We only use AI very sparingly specifically in order to maintain our coding capabilities. That's right. We want to maintain our coding capabilities here. So we're going to do most of the coding by scratch as much as possible. We did scanf. Oh, do we have to do something else? La la la. Like, do we have to do something like that? I think I would get an error. Oh, there we go. Hey, all right. All right. So, I mean, does it want, what does this want? Why is it asking data argument not used by format? What? Actually, what we need to do is we need to look up the scanf specifically. Okay. So I had it right. So it's like enter your name, right, like this. And then this is by reference. Is that better now? No, it's still all right. Then I will. Here's what we'll do. Sam the ham. Let's see if that works. Okay, that maybe worked or not. I don't know. And then we want to print hello. Dine. Let's see if that works. Sam the ham. And it should be less than 10, so we should be good. Oh, well, it didn't quite make it. Do we need a let's try that. Nope. Okay. Let's keep looking. Let's see. Number. S flush. Wompy wimpy hoop. Okay. All right. What? All right. This is what I want. I want to be able to capture data from the user input and then print that out. That's what I want to do. We are very close. I've not done, I don't know if I've ever done scanf before, because usually you don't need to. Usually we're reading data from files or we're saving data from files, sort of thing. So let's keep going here. Looking good. All right, I want to, what's wrong with this? Why is that not doing what I want it to do? Is it because there's no null termination or something? Are we missing something here? There's also an fgets. Ampersand? Oh, do we need the ampersand? Okay. Like that right there. Xerxes, thank you. Ampersand. All right, let's try it. Let's try it with the ampersand. All right, we'll say XERXESX. Okay, so as you can see here, it didn't print it though. It didn't print it. Ampersand, yep, we're back. Hey, Sam the ham. Sam the ham. Can you see what is wrong with this line right here? So here's the line of code. Here's the line right here. And all we're trying to do is capture like your name. Essentially, we want to capture your name and then put it onto the screen. So as you can see here, it printed it's empty data. It printed empty data. And I want it to not print it yet. I want it to print the actual data that I type in. So we did this and it looks like that part worked. Right? I'm pretty sure that worked. So we run it. Although, wait, hold on a second. What is this part here? Hey, Warwick, how's it going? Welcome on in. Good to see you. Happy Monday. What is this? So I need to look up fscan to understand what is. Oh, %s. Got it. So printf. Enter your name. Like that. And then we'll enter the name and then we'll capture it. And then %s is going to be, because that's the data type we're trying to grab into that. All right. And then that will work correctly. All right. That should do the trick, right? That should do the trick. Let's try that. Oh, semicolon. Ha. Thank you too. Hey, there we go. Look at that. All right. We're making our way. Scanf, format specifier, and variable. Nice. Okay. Work. Thank you. Thank you too. I'm beginner and C. All right. We're doing the beginnings. We're in the beginnings right now. We're making it happen. And ampersands everywhere. WSP, WORC. All right. So let's see your test. Does that work? Yes, it does. Yes, it does. All right, that makes me happy. Okay, so check this out. Because of that, let's see here. So Abhishek. Hello, Abhishek. All right, we got you in there. We got you in there. We did it. We did it. Format specifier is the one thing that was missing. Try that code. Oh, and. Is that a fork bomb? I don't know about that. It feels like it's not a fork bomb. It's not. Because if this is in C, if that's a, that might be a fork bomb for your terminal window. Is it? No. Yes. Yes, it is. Because you're running, you've defined a function and. Here, check this out. So this is what SAQ3000 wants us to destroy our system here. SAQ3000 is being malicious. So here is sort of something in bash. So you've defined a function, which is the and function. Then you run the and function twice. And then you run the and function once to get it kickstarted, and you throw that into a background. And then it just keeps running over and over and over. It was just a variable name was changed. Yeah, I see what's going on. We're figuring it out. SAQ3000. I know what you're trying to do there. You start trying to use Vim, maybe? It's Vim here. Yes, you got it. We're doing Vim. How do you split and Vim? So you could split right between there. You could also split vertically, right? You can split vertically, and you can move things around like that. And you can also, I've got a separate terminal sort of window manager called tmux. It's called tmux. And so you can split your window like this. You can also split your window over here, and you can have two like that. You can have three windows essentially like that. That's what I like. It's my favorite way to computer. It's my favorite. Shame on you, SAQ3000. Shame on you. WSP. Yeah, I know, right? Okay, so we did do some dynamic allocation. We did some basically on the stack allocation, heap allocation, dynamic name, where we can type in the data directly. Thanks a lot. Oh, I heard this is needed tmux for do that. Yes. Okay. So tmux to split between different like terminal, so you can have multiple. You get multiple things here. So let's close that. Close that. However, if you just want to split between files and you don't really care about having, you only need Vim, right? So you only need Vim for this. And you can have you can do Vim. Although I really like tmux as well, because then you can do multiple highlighting and you have multiple buffers in memory. So that way you can copy and paste in different forms and fashions, and it makes it so good. It makes it so good. Chilling messing with Raspberry Pi. Oh, nice. Raspberry Pi. That is a great tmux, isn't it? Isn't it great? I like tmux. It's such good. It's a Chalron, why am I only seeing this three-way split now? See, I usually like to just have two windows like this. Usually, you can do another one, right? So you can go vertical or horizontal. It's great. It's my favorite. You know, for Vim splits, you were about and consoles and the console too. Yeah, and the console. I like it. So I usually like having it split between this one, so that way I could see the code up here. I can keep the code here, and then I can, obviously run compile commands here. So like I can add and run. Oh, right. Yeah, I know. Gotta delete some of that. There we go. Okay, so what we covered so far, if you guys were following along, we did basic reading data from the terminal. We did variables that are strings, like this, which are char arrays or char pointers, right? Char pointers, which are pretty much static, right? No, you could probably replace the data there, although problems might occur. Then you also have a dynamic allocation, which then you can scan in data from a user input, and then we printed it all out. Elfo, now let's put a few commas and zeros in your bank account. All right, there you go. We could do that. We know how to do that. Need to free the malloc. Oh, work. Oh, you found, yep. Free dyn name. Yep, there you go. Don't forget your freeze. You can't forget your freeze. Chill together. You got to chill together. Let's chill together, you guys. That's so cool. This is fantastic. I need to free. Yep. Thank you, work. Thank you. Can't forget the free. You cannot forget the free. All right. And there is, so let's see. So we'll say work 974. There we go. There you are. Right there on the screen, you guys. Right there. Right there on the screen. Don't forget your freeze right here. Can't forget your freeze. Thank you, work. Thank you. Good to have you here. Because it's all, I didn't even remember. There is, so in CLang, the CLang compiler. So you see how right here we've got a CLang compiler right here. We're running CLang. Right here, CLang. We have some flags. No problem. Thank you, work. In CLang, let's look at the flags really quick. So CLang, look for memory leaks. Compile time flag. I'm pretty sure there's such a thing. I'm pretty sure there is such a thing. F sanitize and F leak. Let's do F sanitize leak. Let's try this. Let's try it. Let's see. All right, run. Let's see if we can build it. All right, CLang F sanitize leak. You see there on the screen? You see on the screen right here, F sanitize leak. We're gonna hide that. Save it. And then see if it catches it. Wait, hold on. Leak. There we go. Unsupported. Oh no! I really wanted that. That was like the thing I wanted. How do you choose between GCC and CLang or together? Sorry. English bad. Hey, no worries. Your English is great. I'm able to read everything you're saying. So CLang is great for Darwin, right? So I'm running Darwin right here. CLang is great. There's also GCC. I think I have GCC in here. Yeah, I do. So we could also do GCC. I wonder if GCC has this. Let's try GCC. Unsupported sanitize leak. Okay, yeah. So we could do this well. I think GCC and CLang. So I like CLang. It gives you a little bit easier to read error messages. It's cleaner. CLang is just you have no idea. What is Darwin? Oh, Darwin is a Mac. I'm just saying, fancy word for Mac, isn't it? Right? Uname-A. There you go. Mac. Right there. Got a Mac. It's a Mac. So basic Mac, you guys. Yeah. The more we know. We're learning together, you guys. We're learning together. All right. So I would like to see if we can get a compile flag that will be able to catch this problem right here, right? I think we could. So there's also called fsanitize address. Let's see if that works. Let's try GCC. No, let's do CLang. CLang, and we'll say address equals address. Oh, it compiled. It didn't give us any errors. So let me see here. I am looking for a way to detect leaks. See, the compiler should very easily be able to see that I've commented this out. Undefined. Oh, CLang. fsanitize address undefined -G. Okay, we'll do -G for debug. I believe G is for debug symbols, right? G is for debug symbols. All right, and then comma undefined. Let's try that. Okay, so it compiled. It didn't find the leak though. Maybe if we create a function that returns the data. Let's try this. Let's try it. Let's do this. All right, let's make a function. Now we're going into a little bit more advanced where we're going to define our function, char pointer, get name. Let's do something like this, name, like that. No data on the input. And then we are just going to grab this data, put it here. Oh, I want that over here. And then we are going to return dyn name. Actually, well, we don't have to say dyn. We say name like that. Make it simple and clean and easy. I like clean and simple and easy, you guys. Here we go. Now we go char pointer dyn name equals get name. And then we won't do a free. Although we can't. Oh, we can't do that there, can we? We can't. You know what? This isn't gonna do anything. Mummified. Mummified. Good, you Vim so fast. Yeah, I am learning. Nice. Keep going, keep going. It becomes second nature. It becomes second nature, and it does not take very long. It does not take very long. All right, so that's not gonna do anything either. Let's see. Let's do main and end ./main. Oh, Malik nano zone abandoned due to inability to reserve VM space. What? Huh? Test. It still works. It still works, although it's very weird that I'm getting this. So, no, nope. All right. Main, there we go. ./main. This is still going to give us that. It is. So, very interesting. Nano zone abandoned due to inability to reserve VM space. I don't know what that is. I don't know what that means. I've never seen that before. All right, let's do this. Build. Run. Still same problem. Ooh, look at that. Look at all that pretty output. Ooh, look at this. Oh, the G. Oh, it's so pretty. Address sanitizer. Heap buffer overflow address. Oh, because we didn't type anything. You try catch memory leak with compiler, right? You can, although in C, there's not really a try and a catch, right? There's an assert, though it's you basically have to check all the boundaries, and you have to do the best you can to cover all the possible situations that you get in. Otherwise, your application is just going to crash, right? We're in hard mode here. This is C. Steven, check out Zeal docs. Local install and use most language docs in GUI. It's fast to install, by the way. Check it out. I probably won't install it. Even got Vim docs. Ooh, Vim docs. I'll check it out. I'll look it up, though. I'll look it up. We'll check it out. Zeal docs. What is this? Take a look here. Got some Zeal docs, you guys. Offline documentation browser. Zeal is an offline for software developers. All right, let's just zoom in on this. What am I looking at? Offline documentation browser. Oh, that's kind of nice, actually, if you think about it. Because there's a whole bunch of languages and frameworks. And it's, in order to look up the docs, yep, that nice. You have to go to the internet and do a search, or ask an LLM or a large language or chat, ask an AI to help you or whatever. However, if you just use Zeal, you get everything here. Does it include C++? C++? Yep, it's right there. C and C++ is right there. Does it have Rust? Yep, it's got Rust. It definitely has Python, right? Yep, it's got Python. Nice. And Qt, Ruby. It's got everything, you guys. It's got everything. That is really neat. SAQ 2000, thank you. Thank you for showing this. This is great. I didn't even know about that. Offline documentation, you guys. Look, it's so pretty. I like all the colors. So pretty. So very pretty. Okay, so what I should be able to do is say main, run, and happiness. Yep. Now it doesn't crash. What if we do main, and then we control out of that? Interesting. What if we do main and then we immediately can? Okay. Looking good. Also, if you want local wiki, install Quickix. Kiwix. Check that out too. Let's check it out. Kiwix. All right, let's check out Kiwix. Take a look, you guys. Kiwix. Hey, Cardiff, good to see you. Happy Monday. We're currently working on C basics today. We're doing C basics. We're walking through all the different things. When there's no internet, there's Kiwix, right? Is that I'm saying all right? Kiwix? Access virtual information anywhere. What kind of information? Just any information? Like, what is it? Because like the other one, SAQ 2000 that you posted was like very specifically to software engineering. Native application. What kind of data? Let's look at GitHub real quick. Physics, math, programming languages. Oh, wow. So it's sort of like an encyclopedia for all common like I get, what do you call it? Like facts, like well-known facts, and it includes all of it. That's really neat. So it's like all the data. That's pretty neat. A whole Wikipedia. Oh, it's all the Wikipedia. Need to install a Zim file and you got local wiki. Got it. Okay. So you can bring in extra. Sharing web content with people without internet access. Go offline. Kiwix. We're learning new things today. I didn't know about these things. This is pretty neat. That's pretty neat. SAQ 3000. Thank you. You can install it part by part, so you don't have to do the whole thing, because it's probably a lot of data, right? It's a lot of data. So you only want to target very specific things. That makes a lot of sense. Nice. Thank you. Thank you, SAQ 3000. All right, let's keep going. Let's keep going on our C basics here. Let's see. Scan name, return name, char, and then we did free. Let's see here. Clang, build. I didn't see any warnings. And we do and dot versus main. Okay, Malik at this. I need to see what that's about. What is that problem? We'll bring this up here. What is this? Help us, internet. What is this about? Harmless warning. Okay. I want to make sure I want perfection. Okay. This error message is a harmless warning from the allocator. It occurs when nanozone, a specialized memory region for very small allocations. Oh, cannot be reserved. Okay, so we just reserved a very small amount of data, and it was like, you can't get that small of data. You need bigger. You get more data. You get even more. You can't have that much. You need a lot. How to resolve or suppress it. If you want to remove the warning from your terminal output, use one of the following methods. Set a variable, or I guess we could just get rid of the -G, right? Let's find out. Let's find out. Get rid of -G. Is that it? Oh, nope, not -G. What if we got rid of this? Nope, not that either. So what if we got rid of F sanitize? I think it might be it. So let's get G back there. Yep, now it's gone. Okay. Now it's gone. Last week it was machine learning and then software engineering, and now this week C basics. Versatility at its finest. Karthik, yeah. Karthik, you got it. You got it. We're doing C today. We were doing assembly previously. So I really want to focus a lot on machine learning, AI, different algorithms. One of the future streams that we are going to do is focus on the loss functions and all the matrix manipulation functions that you get in PyTorch. That's something I want to learn. I typically do all the matrix manipulations myself. I do everything by hand, manually. I feel like there's some advantage to learning the manipulation functions that are available in PyTorch already. I feel like there's a good chance just to get familiar with them. I want to try them all out, see what they do, print out the, oh, very cook. Yeah, very cook. Cool. I figured I knew what you meant. So yeah, so that's the plan. So that'll be planned for future streams, like some upcoming streams. Right now we're doing some C basics, just getting back to it. Just we've getting rewarmed is what we're doing. We're rewarming. We're getting rewarmed. You're 30 plus and want to change jobs. You try learning programming on your free time. There you go. It's the right way to do it. Did some Python Django, right? ORM, good. Got some Python Django in there. I learned some fast API, nice for web APIs. And you meet C and love it. C is going to give you the most performance that you could ever get out of any language. The problem, though, you got to be careful, is that you can get into accidents and have whoopsies. You can have some whoopsies and get into accidents, you guys. So C will let you, it's a foot, you've heard of a foot gun, right? It's a gun that you shoot your foot with. That's what C is. You can build your application, it will work perfectly fine. Under many scenarios, it'll just crash. C++ is easier to write. Does it have, like, the compiler is a little bit better? Build a neural network from scratch in C? We could do that. It's actually not that hard because it's mostly just for loops on arrays. You can absolutely do it. At least for you, nice. Yeah, I mean, well, then C should also be pretty straightforward. Although I guess C++ comes more with batteries. It comes with extra stuff, which like it comes with a string class of some sort, right? It lets you with C with classes, right? Essentially, is the idea you can create or instantiate a string class, and it's got all these string manipulation functions that are built in for you. So it's a lot easier for you to manipulate data in C++. With C, you have to do all that by hand, customized. Yes, there are some libraries. And you can use them. There are some nice standard libraries that help manipulate some of the basics. Though C++, you're going to have a better time. You absolutely are. You are. You know you are. You know you are. You know you are. Can you write an optimized matrix multiplication function? Oh, ow. Maybe. Although matrix multiplication is one of the most expensive operations other than division, right? So you've got multiplication, expensive, and then division, even more expensive. C is good. C is great. I like C. You missed the second part. Have some request for a realistic way to find a job in tech with no schools, etc. It's even possible. Yes, it is. So I was able to get a job. I mean, but that was many years ago, right? 20 plus years ago. I was able to do that. This now, the climate, there's a lot of sort of non-vacancy. You know, there's not a lot of open roles. The best you can do is just look for entry-level roles as best you can. Even roles that are before entry. So if you're looking for a software engineering role and you want like a junior role, go something before that. Go into like tech support, right? Start with tech support and then practice some of your engineering skills while in that role. There you go. There you go. That's a good one. That's a good one. I like that one. If that helps you, let me know. Let me know if that helps you. Okay. Okay, let's see what else we got here. What else do we got? All right, so machine learning is a good career path for future. Yes. Also security. Security is another good one. Tech support. Tech support, yep. Do tech support. See if you can get a tech support role, especially when it has to do with tech support for other software engineering situations, right? So if you're tech support for an API company, that's another good one. Stephen finally checked this out. Zim Wikipedia. You can download all of Wikipedia. SAQ 3000. Are you serious? You can download all of Wikipedia. All right, let's check it out. Can I copy and paste that? I don't know. Let's try this. All right, we'll see if we can get to it. All right. Wow. Oh, wow. Wait. Oh, look at these right here. That's a little bit of a data right there. Only like a few 100 gigabytes or so. You'll check this out. Thank you. Hey, great to hear. Great to hear. Happy to help. That's a lot. That is, I don't even know if a computer, you need a very big computer. A big hard drive at least, right? A big hard drive. Wow, look at that. So much data. I know, Kartik, seriously. This is all of Wikipedia. Isn't this ridiculous? Wow. Oh, and that's just for it's very specific things. Chemistry, climate change, sports, mathematics. Ooh, mathematics. How big is mathematics? Not that big. Not much that into mathematics. You don't need that much space for mathematics. Medicine, pretty big. Movies. Movies is bigger than mathematics. Dude, look at where humanity is spending their time. It's ridiculous. You installed what you needed, not everything, just sudo apt install. Nice. Got a Debian installer there. That's great. This is really neat. SAQ 3000, thank you. Chemistry, got some chemistry. More climate change. Some more basketball. Is this just looping? There's more basketball. It keeps saying basketball. Oh, it's because there's snapshots. Maybe they're snapshots from older. Are they older snapshots? Yeah, they're older snapshots. Okay. So you want to get only the latest data. Get the latest. And then you can keywix serve port 8080 star.zim and open in a browser, and you'll have all the data that you ever thought. It's new and old. Got it. It's got both of them. Nice. Very nice. Okay. All right. So let's see. How much time do we have here? Okay. We're doing good on time. Actually, I'm pretty happy about this. We're doing okay, you guys. We're doing okay. So we do have to get going. Maybe in about, we'll give it 10 more minutes. Hey, David. How's it going, David? Hi. Good to see you. Welcome on in. We are doing some C basics. So we just covered writing a function. We just cut with a char pointer, mallocing the data, which I'm pretty sure it works. I don't know if this is like the best way to do it. It's just the way that it worked. Scanf to read in data. Maybe one day, out in space will remember me. Yeah, we will. We will. It's going to happen. It'll happen. Doing good? Nice. Good to hear. Good to hear. So let us see what else. All right. What else do we want? I think it would be neat to see if we could do a function pointer. Now, I'm going to try to do it from memory. I'm going to see if I can do it from memory, I think. So char do something. And then we want to take in a pointer to a function. So we're going to do a callback here. Callback. I forgot how to do this. Void callback. Can we do it like that? And then we run callback. And we'll put like a number into it. Or we'll just keep it empty. We'll keep it empty. Will this compile? And are we doing this right? Does the star go here or here? Do you remember? I don't. And we don't want to do it. We want to do it like that. Can we do it like that? Callback. All right, let's see if that runs. Build. Okay, so not that. We're gonna have. I'm probably gonna have to look this up. Is what I'm gonna do. I'm probably gonna have to look it up. It doesn't like that. Get the syntax freak here. Nope, not that. Oh, maybe we do it like this. Void star callback like that. Oh, hey. All right. Well, no, I think it just got confused by the syntax. No. Maybe like that. Nope. All right. Let's look it up. Let's Google this. I want to try this. C function callback param. How do we do this? C function callback param. All right. How do we do that? Oh, where callback? Oh, without a typedef. Can I do it without a typedef? I'm kind of curious if we could do it without a typedef. Yes, we can. Maybe. Here, I'll show you what I'm looking at. Here, you guys. Here we go. Okay, let's see if we can do this without a callback. All right. Without typedef. See if we can do it without typedef. Is it possible? In C, function that accepts callback without using typedef must be declared the function pointer signature directly as its parameters. Yes, that's what I was trying to do. That's exactly what I was trying to do. Okay. So void, and then the pointer callback. Callback pointer name, and then, all right, perfect. And so that'll be your callback. All right, let's try it. Let's see if we can get this to work. So it looked like this, star, like that, void. And then it will be an int right here. Excellent. Okay. We're going to do something with data, and it expects an int. We'll say, we'll just say char 1, and it just returns 1. Return. Well, return. Maybe we'll just do a pass your int number. Okay. Okay. See if that does anything there. I'm going to call back and we'll put the number like 10. Let's say return 12. All right, sounds good. 12. Or we could say char out equals 12 like that. We just say out. Okay, is that going to build? Do you guys know if that's going to build? I don't know. Let's find out. Oh, see if that works. All right. Callback. Is this correct? Yep. Callback. Star. Looks good. All right. Void return. Oh, int. 1 second. All right. There we go. Hey, there we go. All right. Now we're figuring it out. That's what I'm looking for. That's exactly what I'm looking for. All right. Did you know you could look at this syntax? Isn't that crazy? Isn't that obnoxious? Although it's a great way to allow a user to inject some of their own code. This is a great pattern. I like this pattern because it's a great way to allow a user to call a function, but then inject their own code at a specific point. It's kind of a neat pattern. Obviously, now we're not talking about the basic. I know I keep jumping past the basics. I know we're saying the basics. Okay. Let's see if we can run that really quick. Let's see. We'll see. I don't get int. This is char function, but pass int. Yeah, I know you can. I know, isn't that weird? You know you can do that. It's because they're both numbers. They're both numbers. Char. There we go. Yeah, here we go. Char. They're both numbers. Here we go. See, now there it still works, right? It still works at first main. Looks good to me. Looks good to me. Work. Yeah, good point, work. Good point. We should keep things consistent. We really should. We should keep it consistent. Oh, we forgot another char here. Char. They're interchangeable. Okay. C-lang main. Okay, great. Okay. Let's try running the code now. Let's try running code. So we'll do something, and then we'll pass in 1. We'll pass in 1. Okay. You could also, if the user is going to do something like JSON data or some sort of unstructured or non-literal, a non-stack variable, you could see so permissive. It kind of is, right? A little bit, just a smidge permissive. It's just a smidge permissive. Just a bit, isn't it? Just a bit permissive. Okay, so let's see if we can run that now. All right, let's run that. So char number equals do something, and then we'll pass in 1. I think we'll just pass in 1 like that, and I think that'll work. Maybe we have to do something like that, like with dereference like that. With that, I don't remember. We'll try it. We'll try it. It worked. What happens if we get rid of that symbol? That works too. I don't know, man. I don't know. All right, here we go. Let's try running it. So this, I should be able to say printf %digit number, and it should return 12. Right? It should return 12. Well, wait. Hold on a second. Yeah. Yes. I think we're not using 1 though. Oh, we are using 1. Hold on. This is getting confusing. I need to clean this up for a second. Hold on. All right, we're going to do something. We want it to pass a callback. And the callback is just going to do a pass through. All right, I guess it's going to work. Wait, 1 is variables. It's also a function. Isn't that weird? Isn't that weird work? I know we're getting weird. I know we're talking about basics, but hey, it worked. There we go. Look at that. Here, let me just give her that. All right, so let's see. We'll do like we'll make a bigger number. We'll make a big number. We'll say 974. Does that mean anything to you, work? I'm kind of curious. 974, because it's in your name. It's in your name. There we go. Print. Wait, no. Run. Okay. Oh, it's too big. It's too big because it's a char. All right, let's change all the chars. s/char to int. There we go. Okay. Now it'll work out for us, main. Hey, there it goes. -50. -50? Are you kidding me? That can't be right. That can't be right. Hold on a second. Oh, because I got to do int here. It wrapped, you guys. It wrapped. Do unsigned integer. Okay, so now you guys, C permissive. C permissive, you got it. There it is. All right. So my question to you, Warwick, is, does 974 mean anything? What is 974 to you? I'm actually really curious about that. What is that to you? Let me know. Yay. Yay, we did it. We did it. Isn't that neat? I think it's pretty neat. So you can use that pattern. I like this pattern. It's a really neat pattern. It allows you to create a function that then allows the user to define their own function to call code at a specific point. Really great for scenarios where you want sort of the internals to be reported back to the user, and the user can make a decision on how they want to export that data. Are they going to export it with stats D, or are they going to export it with a Prometheus endpoint of some sort? Are they going to store the data for heuristics? Do they want to print the data straight to standard output? There's so many ways, and that is a really great pattern, specifically in production that I like, to allow the user who is the developer that is implementing their code and leveraging the function that has the callback enabled in it. How is the number of your French? Oh, it's the number of your French department. Oh, interesting. What do you know? I don't know. Because see here, I'll show you. It shows up as your name. I don't know if you can see it. So like, it's kind of here. It's like zoom in. Work 974. It's right here. Work 974. There you go. Work 974. Okay. I'm curious about Steven's psychology. Tell me more. What do you mean? What are you trying to get at there? All right. So we did functions. We did function pointers. And we've got maybe another 5 minutes, I think. I think we got another 5 minutes here. What else can we do? So we did function pointers, which is pretty neat, right? So we did that one. Let's go ahead and mark that as done. Check. Here we go. Check. We did string chars. We didn't do anything else, basically. We didn't do anything else. How's Steven happy all the time? Well, you got to eat good food. Eat healthy, right? When I mean eat healthy, I'm like vegetables and fruits and nothing processed, right? No sugar. Keep things clean and easy. That's one. That helps a lot. The other is do the things you want to do. And guess what we're doing right now? Guess what we're doing right now? That helps a lot. That helps a lot from happiness. It helps a lot from happiness. All right, so by reference. So maybe we can do this one last one here. Let's see if we can do a by reference instead of a copy. Okay, so let's do a function with by reference. Let's make a new file. Let's close that out. Git add. Let's see, mv main c2 main not main. David, how's it going? Where can I find those exercises so I can repeat it after watching? We put it on GitHub. So David, I put it on GitHub. I uploaded it here, right here. So I added it to this GitHub right here. So you got our calc, and then you've got a couple other things, and we're going to put all of that here. And it's called C Basics, and we'll put it on Discord under our link share. Here you go. Link share. There you go. Right here. C Basics with Steven. C Basics with Steven, you guys. Okay. So it is on our Discord. Let me also change that. So this is going to be function pointers dot C. Okay. Let's go ahead and let's copy that. CP function pointers to main.c by function pointers. All right. Let's get rid of this. Function pointers, clean that up. Let's make that a little bit nicer. Function pointers. Let's get rid of this. We got a function pointer there, and let's get rid of that. All right. There we go. Function pointer. Perfect. And I will commit this. All right. Thanks a lot. Thank you. Thank you for being here. Git status. Wait, hold on. rm main.d star -rf. Git add. Okay. Oh, rm main. Let's see. I need to. All right, what files we got here? Okay, calc thing. Okay. This will be function pointers. Push. All right, there. So it should show up here. And there it is. Here you go. Function pointers. All right, very easy. Very easy. Well, not really. Not that. A smidge easy, right? A smidge easy. This is, if there's one thing that you wanted to learn and take away from the stream, if you are either a seasoned C engineer or just getting started, I think this is a pretty good one. Work, thank you. Yeah, I like this pattern. This is one of my, a very satisfying pattern. It's a very satisfying pattern. It allows you to do some nifty things. Some nifty things, you guys. Some nifty things. All right. So, one moment. Hold on a second. Let me. I gotta type to someone real quick. Okay. Okay. All right. Sounds good to me. Just typing some messages real quick, guys. Okay, go back over here. All right, I had a direct message that I had to get into. Yeah, it's very good teaching. Nice, David. Thank you. Happy to help. It is very powerful. It is very powerful. I love it. You can go even further with function pointers that give you access to put any kind of data. So if you're trying to do things like with linked lists or your own heap, your own hash maps, whatever you're implementing, any kind of data structure or algorithm, you can also use void pointers. Void pointers, function. So instead of saying like an int, you could say void or void pointer, which will allow you to get reference to data, like any kind of data that you want. And then you can, when you grab it, when you grab the data back, you just cast the data. You cast it to this specific type. Either it's a struct, probably it's going to be a struct, or it's a literal data type like an int or a char or something like that. You can do that. You can do that. All right. Before we go to the next thing here, let's see what we want by main. We did these guys. Let's do another one. Let's do by reference. All right, let's do data by reference. Now we're into the basics. Now we're getting back to the basics. Obviously, I don't know, that one at the top, a little bit beyond the basics, but that's fine for now. Let's do a by reference. Let's do by reference. Okay, so let's do by reference.c. Okay, so let's bring back up main, because we got to bring in some of our libs, common libs there. Although I don't think we need string in this case. We might not. So int main return 0. We don't have to return 0. You can. We found out earlier. Let's see. Let's clang. We want it to call. What was this called again? By reference.c-o by dash reference. And then let's see if that works. All right. And then we do ./by. Excellent. Okay. So let's do a function. We'll create a function here. Let's see. Copilot disable. Okay. So we'll say int function, and then we'll take a reference int. So this will be int pointer, I think. Pointer to a reference. So this will take an integer that you defined, and it will update. So actually what we'll do is we'll do void. We won't return anything. We'll just modify the data. So we'll say int my number equals 100. And we'll say function. And then we'll say, let's add. We'll call this add 10. Call it an add 10. My number. So now, technically, you have to do an ampersand here. Technically, because it takes it passes the address, right? So we get the address here, and we say let's say number plus equals 10. Can we do that? Does C let you do that? I forgot. I don't know if we could do plus equals 10 or not. Let's try this. C lang build. It worked. It worked. It compiled. Hit. All right. Now we need to print it. All right. So we print before. Print F %D because it's a number. My number. I think K, it's work. Me too. I think it's working. It's great. I'm just like surprised because it's kind of neat. We'll call it before, and we'll do after, like that. AFTER. Before and after, you guys. All right. So now we should see on the screen. We should also add a new line character there. We should see a before with 100, and an after should be 110. And as you noticed, we're passing it by reference. Build and run. Hey, oh, that didn't work. Hey, that didn't work. All right, we got a problem, you guys. Look at that. We have a problem. It didn't do what we wanted it to do. Why is that? Why that? Let's see. Let's try this. It wants that. What if we do that? I don't think that works. I think you have to. I'm pretty sure. Well, number equals number plus 10. So it's still right. It should be a bit, right? It should be. Thank you for the floaty heart icons in the hundreds there, you guys. It obviously ran and it didn't crash. It's not giving us the output that we want though, right? It's not giving us the output. Why is that? Yeah, put an ampersand there. Passing argument parameter number here generated an error because so obviously, but it's not doing what we want. This is not. Oh, thank you. Yeah, all right, work. Thank you. All right, so we have to do some dereferencing here. Is that what we got to do? Got to dereference. Could do that. Does that work? Hey, Work, you figured it out. Thank you, Work. Thank you. I wonder if we can do plus equals. Can we do plus equals? Does it already know? Let's try that. All right, let's try that. Yep, there it goes. Plus equals works too. Yep. You gotta gotta dereference it. Dereference it. That's where you gotta. Yay! We did it by reference. And so it takes the data and it mutates the data. And while it's not in computer science these days, right? In production, in the industry, you want to stay away from mutation as much as possible. You want to always create new data. Create new data where you can. Obviously, it's a little bit slower from a safety perspective, though. It's better. It's better. Nice. My basics are a little fine. Yeah, they are. You got it. One little missing symbol is all it took right here. The little star symbol, you guys. You gotta watch. That's right, Mike Hale, good to see ya. Welcome on in. Happy Monday. We are getting C basics going in. All right, so we did pass by reference. Okay. There we go. A nice example. Happy and so good. Easy. All right. Get status, get add C, get status, get commit. We added by reference example. All right. Getting things right. We're actually doing the basics now. We're doing the basics. We're taking care of business here. We're actually taking care of the business. You got to watch the if the pointer is null. Oh, the program will crash. You bring it. You drive a hard bargain. Mike, you drive a hard bargain. All right, we got to do, this is important. What Mike just brought up, this is really important for everyone who's watching. It's really important. We do have to check the user input. We do. If number is null, then we need to just return. And I like to do it like this. I know it's not like, it's just easy. It's not, some people are very, very strict about their indentation. So in terms of style guidelines, you could do it like this. I like to do it all in one line. Hey, welcome back. 199. Good to see ya. Happy to see ya. All right, so you can do it like this. I prefer like this. Whoops, no. A little bit less. I prefer it like this. There you go. So that will also work. So let's go ahead and build that. There you go. Perfect. So we got to check for null. Got to make sure to check for the nulls. Thank you. Thank you, Mike. Thank you. All right. Validate user input. Ish, to a point. All right. Obviously, int is going to be a number, so we don't have to check any boundaries on the numbers or whether anything else. We're just going to add 10. Okay. Git add by reference.c. Oh. I have two different spellings. Isn't that great? Reference. Which one's the right spelling? Let's see here. Which is the right spelling for reference? All right, so this is the right spelling for reference. Micah, please. Mike. Oh, Micah. Micah. Okay, gotcha. Micah. Not Mike. Mike is too American. Okay, gotcha, Micah. All right. Sounds good to me. Okay, MV by reference to by reference. Let's make sure I got the spell right. Micah, you guys. Micah, thank you for the likes, you guys. Hey, how's it going? Is it Saria Stover or Ciara Stover? How's it going? Good to see you. Hey, Neva. Wow, you streamed for a while. Kind of sorry I missed most of it. Hey, no worries. We're doing the C code now. We're doing the C code. The thing that we promised that we were going to do the whole time on the previous few streams. Although we had to take a little break there because we had to get prepared for some stuff. Right? We did some paperwork, you guys. We did some paperwork. Hi, how's it going? Can be Micah. Can be Misha. Oh, Misha. That's the nickname for Micah. Misha. I'll try to remember that. I'll try. Misha. I will do my best. Hey, Neva. Good to see you. Glad you're here. We are doing C basics, and we actually did a C basic. We did a real C basic just now. We just did the real C basic. All right. Git add. Wait, hold on. ls. Git add dot git commit. Git status real quick. Git commit by reference example success. And stream helped too. How's it going there, Anthony? Anthony, good to see you. Welcome in and happy Monday. We're doing git push here. Git push origin main C basics. We're doing C basics. So we just did by reference. All right. What else do we want to do? So we did the by reference on C. Looks good. We could do structs next. Let's do some structs. Let's see if we can get some structs going. So let's close that. CP, let's see here. Vi structs.c. Okay. So, main, there we go. So let's type all this by hand. Let's go. Include std lib and wait, hold on, wait. R copilot. Vi is enough. No need for Vim. Oh, we're doing Vim. So here, check this out. I'm on Vim. Here, so this is the Vim version I'm on. I'm currently on version 91754. It works perfectly fine. We're using Vim. Vim improved. We're using Vim improved. Hey, Drawing Brothers, good to see ya. Happy Monday. Welcome on in. We are doing C basics today. C basics. Okay, so let's copilot disable. Okay. Include std stdio.h and we'll do std lib. There we go. Why does that look weird? Oh, there he goes. Okay. Perfect. ty. Oh, look, it's alias. An alias. We got an alias in here? An alias. Oh, aliases? Oh, it is an alias. That's what, yes. I made that alias like maybe 20 years ago. So it's been a little bit. I made that. You're absolutely right. It is an alias. You got it. It's an alias. Yep. So vi is an alias to vim, right? These are aliases. There is. So vim is the same as vi. Yep, they're the same. They're the same. You got it. Now I use Dvorak keyboard. I did for a while. I did. I used Dvorak keyboard for a few months. I did. Oh, Vim is so old, isn't it? It works great though. It works fantastic. Do you use Vim motions? All the hacky stuff? For the most part, I use all the hacky stuff. I love it. I all the time. Yeah, I use all the different keystrokes. How to love Rust. I've been following the Rust book for days, but still I couldn't fall in love with Rust like crazy. Drawing Brothers, Rust is fantastic when you're deploying to production because it takes all of the pain and you still have the pain. It brings it up front at compile time instead of when something's in production. That's what brings you love for Rust. And that's what I did at my company. We've got Rust running in production. It's fast, performant, and it keeps you sleeping. It doesn't wake you up with alerts because it runs fantastic in production. That's the draw, the appeal, and the reason why everyone loves Rust, because the compiler takes care of everything for you. It's so good. It's not for everyone. If you code in C++ for a while, you're gonna be like, thank God. Yeah, you're right. You're absolutely right. Yeah, Rust takes care of concurrency safety and memory safety. And the big one is concurrency safety. If you didn't know, that one's a really big. Rust easier than C++? Well, C++ you'll probably be able to get away with more quickly. Rust has a lot of patterns that are hard to get used to. And so it's a little bit of an inversion on, if you've been a programmer for a while, Rust will kind of change some of those practices and you can't get away from it. Yeah, it depends on what you mean by easier. It does. Yeah, it does. It does. I think maybe C++ is easier than Rust. Rust is going to be harder. And just because the compiler is very strict. Okay, what file? We're doing structs? Okay. Struct. How do we do structs? It's been a while. It's been a while since I've done struct. So let's do struct. We'll call it person. Name is a char pointer. I forgot how to do this. How do we do structs? Let's go. Structs. C example. There we go. Let's see if we get a struct here. I just need the syntax really quick. Okay. So it's a little bit around char pointer name, like that, semicolon. Okay, name, and then we'll say int age, something like that. So we got a person here. We got a person. C++ changes every 3 years, so you need to relearn it. They do. The compiler keeps upgrading and getting better and stronger and better and stronger. Easier to correct, harder in general. C++ has things that make it hard. True. Polymorphism. Why do you even need polymorphism? You're missing the semicolon, like right here. Thank you. Hey, was it? So, Micah or Misha? Misha. Thank you, Misha. Thank you, Misha. Remembering your name. All right, so that's struct person. All right, so int main. Let me get main going here. Return 0. And then we need to allocate a person. I forgot how to do that. Or you could put it on the stack. I forgot. You could put that on the stack. You could do a char pointer, or you can give it like a limit. So you can say your max name will be 10, right? So you put a limit on it, like 10. So you could do that. And then we say struct, we'll call it Misha. M-I-S-H-A. We'll call it Misha. We'll do lowercase Misha equals. Oh wait, no, person. Person Misha, right? So that should define it. And since there's no chars or anything like that, we don't have to do any mallocs. You can allocate via malloc, calloc, or alloc. Alloca. Yeah, you can. You can also do it straight on the stack. Because if you look here, it's actually pretty straightforward. It's designed, and there's nothing to allocate. There's no dynamic memory in this case, because we're predefining. If we did like char name like this, then I think we would need to update the actual value with a malloc. Alloc is kind of wild. Like, you need some flags, right? I've not used alloc myself. I've only ever really used calloc and alloc, mostly just malloc, because it keeps things fast. All right, so that should build. Let's confirm this builds. clang. What was that called? Struct -c-o structs. See if that builds. It doesn't like that syntax. Oh, because I'm doing it wrong. Silly. If you don't know the size, it will crash. It will crash. Yep. All right, so there we go. And then we should also be able to run that. ./c and ./structs. There we go. Perfect. Okay, so it runs. Happiness. There we go. If you like to overflow the stock. If you overflow the stock. You could. The stack size. Oh, gotcha. Yeah. Okay, got it. So if we go above 10, is what you're saying? If we go above 10, then yes. So we'll say, can we, kind of serious. So Misha.age equals 1000. We'll say 1000, Misha. And then Misha.name. Can we do this? Misha. I don't know if we can do that. I feel like we can. I feel like that'll work. And then we should say printf. Name is %string \n, and then we say Misha.name. I'm pretty sure. 8K for main, 4 for thread. Oh, right. The max size. No strings in C. No, that won't work. It won't. Are you sure? I don't know. We'll find out. Won't we? We'll find out. You gotta use strdupe for pointers and memcopy. All right. Build. Yeah, you were right. Char is not assignable. It's not assignable. You can't do it. It won't work. Okay. So instead, since this won't work, you have to do it a different way. You have to copy the data. I think something like that. I think something like that. Right? So then you get the name. Oh, I need to include strings. Okay. String. There we go. Excellent. Or memcopy size of. Oh, right. We could do memcopy size of. So this is string copy. And you can also do memcopy and then size of. Because it's a const char. Yeah, like char name 10. It's an array. Yeah, exactly. Like it's 10 chars. It's 10 chars in a row. Hey, Fractal Cow, how's it going? Happy Monday. Good to see ya. All right, there we go. Misha, we got it. All right, let's do the name next. Or the age. %digit. And we'll say Misha.age. There we go. Init on stack, and then we say assign, not assign, assign data, and then print. There we go. That should do the trick. str copy is fine here because we know Misha is less than 10 chars. You might want to do and assert on size of string, and then str copy. Yes. That would class is person. It is. Omar, you're right. It's kind of like that. It's kind of like that. So your char can't have more than 10 letters. You got it. It cannot have more than 10. And I do believe it should actually still be fine if we were to. So here, let's put it to the test. Let's put it to the test. Let's say 2. Let's put it to the test, you guys. Wait, before I do that, let's see if we got this building out here. So we got name and age. We're good. So let's put this to 2. What happens when we put it to 2 here? Is it going to break? Is it going to explode? Or are we only going to get the first 2 letters of Misha? Yeah, you know, I don't remember either. We're going to try it out. So are we either going to get MI is the name? Nope, it's just going to outright fail. It doesn't even compile. Yeah, there it goes. We got a compiler warning. The compiler protected us, you guys. The compiler protected us. Look at that. I've never seen C protect us that way before because we're on modern compilers, you guys. We're on modern compilers. No, Frank, the speed of your Vim writing is a blast. Is it? Work? Yeah, got it. Thank you. Thank you for the compliment. You're going to copy over your return pointer. Not good. Can't have 9 letters plus null terminator. Yeah, you got to have the null terminator. You got it. It's a warning. You can still run it. Oh, yeah. All right. So let's do this. Okay. Delete. All right. So we got, it is a warning. It's a warning, right? It's just a warning. So that means it should work, right? That means it should work. So if you /structs, str, trace trap, it ran and then it didn't anymore. Trace trap. It failed right here. It failed. Yep. Because of assert. I think it asserts. So let's see. Let's see here. Assert. Let's do it. Let's do our own assert here. Do we have to import? Okay. Let's see here. I think we might have to import. Are you university academic? Sort of. Yes and no. Yes, because I did go to college. I did go to university for 3 years, and then I dropped out. Make a char for Misha, then do compare. F-sanitize address and undefined. You need to include assert. Yes, assert.h. Okay, got it. Assert.h. Or you can do ASM int 3 for a trap on x86. I'm not familiar with that. I didn't know you could do that. That sounds pretty neat. Let's try assert. Assert.h. Okay. Assert. How do we do string length? strlen. Greater than. Less than 10. Right? Because this includes. This right here, this part includes the. Because it's 10 up here. Let's do 10. So and then assert. What do we do? I think there's more to assert afterwards. Oh, no, that's it. That's all we got to do. Okay. You need string header? Good. On C-link, string.h. We got it. Thank you, Misha. All right, so assert string h. You have this. It's fine. Nice. All right, so assert. Now it should work perfectly fine. Build and run. Success, you guys. Success. I mean, this is a little. What if we did? Let's do 2. Let's see what happens when you do 2. Build. All right, now run. Assertion failed. Yep, because it exceeded the limitations. So that's what it looks like when the assert goes beyond the limitations. You can do size of Misha because it's a static size. So, like best size of. Oh, okay. There we go. Let's do that. All right, we'll update it. Neves has a good recommendation. Size of Misha. And then less than or equal to. We have to go over here. Has to be after, right? Because we've already copied it at that point. Oh wait, no. It's got to be before. because we size of Misha, that name. There we go. Now we're into it. Now it's a little bit better. Now it's a smidge better. You can use man3 function name for more information on the terminal. Man3. Oh, man3 size of. Man size of. Man assert. Hey, there we go. There we go. Ooh, I like this. Hey, Misha. Thank you. I remember I used to read these manual pages all the time. Many years ago. Can we do... I'm actually kind of curious. Man epoll. Oh, there's no epoll. What about KQ? KQ. There is a KQ. There's a KQ right here. Man4 for size of. Man4. Man size of. Man std lib. Nope. There's an stdio. I might not have all the man files installed. Obviously, add agent. Mohammed, how's it going? Add agent for 56 million. Work with Misha. I'll try that. Man for size of. It says not. Sadly, I have to go. Oh no, work. Thank you for all the check with. Sounds good. Try to catch next lives. Good evening. Sounds good. Thank you for stopping on by. Happy to have you here. Having lots of fun, you guys. Having lots of fun. Doing the C basics. All right. We'll do one more C basic. Let's make sure this builds. Let's make sure this builds really quick. Builds, and then we run structs. Looks good. Okay. Git add structs.c. Git status. Git commit. Oh, git add main. What do we do to main C? Git blame main.c. What do we do? We just upgrade. I'll write it. All right. Main.c. And then we did structs. There we go. There we go. I don't know if Mac is different. Yes, Linux would be better. Unions. Unions are great. Because you have structs. You might have struct, right? We got to add unions. Thank you for subscribing, Task. Thank you for subscribing, Task. We're going to add unions. We're going to do it. We're going to do unions. Unions. We'll do unions as well. We'll do unions on structs, right? Unions, right? Unions. Thank you for subscribing there, Task. So this channel is about software engineering. My name is Stephen Blum, CTO at PubNub. We have over 1 billion connected devices and 68 patent claims that have been granted that are based on my technology. Yep, my patents. Been in technology and the industry, being paid for 25 years, and been professionally coding for 25 years is what you should say. Savon, hey, I'm resting, watching the live. Nice. Unions are. They are. Yep. Maybe after typedef struct person. Yep. Oh, so you can do. Yeah, the shorthand, Misha. The shorthand. Yep. Let's add that in. Main. We'll do typedef. Typedef. Let's see here. Over here. Close that. So, right. So you can essentially. Make it easier. So you don't have to use the word struct all the time, right? You can make it so you don't have to use type person. Yeah, exactly. Without struct. Exactly. Type defs. We could do that. You know what? We could add that. Why don't we add that in? And then let's see here. Structs. Okay. Close that. All right. So we could do, so you do type def struct person as person. I forgot how to do this. You can type person without struct. Yes. This is C99. Also. Yep. Exactly. Is this how we do it? I forgot. Is that the way? I feel like that's wrong. Let's try it out. It compiled. All right. See if we can do person now. So you can see it's a person. Okay. See, build. It built! All right, let's see if it runs. Struct. Does that look right? Is this it? Does that look correct to you guys? I just made it up. I just made it up right on the spot. So, and it compiled, and it didn't give me any problems. It did exactly what I wanted to do. I think it would be technically compile as 89 right now. Okay. Type it before the struct keyword. Oh, I suppose we could do here typedef like that. Is that what you're saying? Let's see if that builds. It has an issue with that. Oh, I think we have to do person, right? Like that. That'll work now, right? Now it'll work, right? Now it'll work. Let's try it. Nope, just kidding. Oh no, there it goes. Okay, perfect. Okay. There. See, I knew it. I knew it. I was like, I'm pretty sure that works. I'm pretty sure. I was pretty sure, you guys. Typedef keyword. We did it. We did it. Similar to static and storage class, CS grammar is ridiculous. It's ridiculous. It is ridiculous. Steven, try this in your terminal. I don't think so. Cat a.py. Oh, and type code there. That won't do anything. Cat a.py doesn't exist. And the end type EOF to exit. We don't need text editor. Really? Wait, really? Are you sure? A.py. Yeah, see, it just doesn't exist. It doesn't work. It's what I thought. That's what I thought. But why write C directly when you could just use nim? I know, Michaels. I knew it, Michaels. I knew it. How's it going? You could just use nim, exactly. Ridiculous. I know, right? Hey, Fractal Cow, just making things up, and it works. Isn't it great when that happens? Isn't that great? So we added typedef. So here, so there's different ways to do it. You could do it this way, right? You could do this way. I think I like, because this is a bit much to read. I do like it. It is clean when you do it that way. I like this pattern better. Because it's more, you can see, although it's perfectly fine otherwise. Like this right here, perfect, perfectly fine. This is perfectly fine. It's auto-saving what you write. Try that. Cat a.py. I don't think so, dude. I'm pretty sure SIQ 3000. You can create that file with, yes. You can absolutely, right? In Bash, you absolutely could. What I do is, like, yeah, right? I like doing this, just regular a.py. Like, that'll work. That'll work fine. Wait a second. This is so much better than tutorial hell. Fractal Cow, isn't it? I think it's a lot more fun because we're trying to make things work, and we remember. Got to get the memory going. Jog the memory, you guys. Jog the memory. Yeah, I like this pattern. This is great because it's clean. It's, fewer lines of code, right? Because you're reusing the same lines of code that you had before. So this pattern of typedef is actually pretty nice. You're still typing the name person twice, right? You're still typing it twice. So it's fine. And then there's this approach as well. And then you don't have to type struct in front of person anymore, struct like this, because you've typedefed it. It's now its own data type. Its own data type. I recall, loved the feeling, bare metal when I had to use size of struct name, size of buffer to malloc, a dynamic mem for a couple of records. Isn't it? It's its own feeling. It's own feeling. Stealing, it's nothing malicious. Come on. It's just auto-saving. When you type code, then say EOF after, that saves the code. No. No. C is tricky, Anthony. You're right. C can be tricky. You can even remove the person from struct person. Oh, so I don't have to type it twice like that? Let's try it out. Okay, so let's try that. Like that, you said? Never like that? Let's see. It seems to want it though. Person. It likes it. It likes it better. It likes it better. See? It doesn't like it when it's like that. It likes it like that. It likes it like that. Compiler happy. Compiler happy now. Typedef person. Although, let's double check. I think you have to type person there too. I'm pretty sure. Try it in Docker if you don't trust me. It's cool. Terminal trick. Is this a bash thing? Because I'm not using bash. I use Z shell. I use ZSH. If it's a bash specific thing. You append end of file to that redirects to cat, which concatenates files to create the file. So that's just not going to work though. So cat a.py. I'll try it right there. Pi. Then you type a bunch of stuff and then type EOF. Nothing happens. Type it. Typedef struct person. Person, right. Yep, exactly. Person. Oh, like this. Like that. Oh, never. Okay, got it. Let's try it. Hey, there we go. That's clean. Never, thank you. That's clean. I love it. I'm very satisfied. It's bash specific. Got it. Okay. You need the operators. Yeah, I figured. Yep. Got the operators. Hey, Neva, thank you. This is a lot nicer. So we could probably say whatever we want right here, right? It doesn't matter. We can put whatever we want right there. And it will compile just fine. You can put whatever you want here. Whatever I want right here. Whatever I want right here. And it doesn't matter. C will just be like, I don't know what you're doing, but there you go. You can type anything you want right there. Isn't that crazy? Whatever you want. It doesn't matter. I love it. Yeah, that's the pro's way of doing it, unless you want to write the name above. So, Neva, thank you for reminding me. Yes, so I do have this. So in my message bus, my technology that I've got my patents on, I wrote it in C. And I'd use an extensive amount of structs. And I did typedef it, and I did it this way as well. I would like to show you, although it's proprietary and it is closed source. So I wouldn't show you live over the internet the source code. Though you just gotta trust me. I did type it the way that you're describing here, and it's just been a little while because we're doing everything in Rust now. Everything's in Rust. It's all in Rust. Either or both. Identifiers need to be different. Got it. No, it works in ZSH2. Google search here doc. The terminal trick name. Okay. What's a typedef? Okay. A typedef just allows you to define your own data type, essentially. And not really, and really in a way, it's just going to allow you to alias data type when you're defining it. So you see here, we've got a person is Misha or Micah, and it's going to instantiate on our stack a struct. You can do typedef differently, right? You can create your own like number, for example, typedef int as my int, something like that, right? That should work. Here docs. So it allows you to create your own data type. So right, unsigned int, right? Wait, hold on. Unsigned. So you can say, I don't know, let's call it my int or whatever, and then you can use that as your own data type. And so it's like it's like kind of like an alias, really. It's kind of like an alias. So it's like an alias. Like an alias. Like that. And that'll work perfectly fine. It's a pre-processor or predecessor of class. Hey, Anthony. Good point. Predecessor. Or is it typedef is a macro, or is it reserved? I think it's color coded, so it must be. It has to be a key. It's got to be a keyword. It's absolutely a keyword of some sort. Steven, why don't you trust you? Well, I would. I tried it. I typed it in and it didn't work, right? So wait, what'd you call it? You called it here doc? Here doc example. Here doc example. All right, let's pull that over here. Oh, see, yeah, this will work. I know this part will work. Yes, so you have to do it this way. So that part works. I know this part works. I know that part works. It's a storage class. Weird. It's just a storage class, like a static or extern. Oh, common thing we see because people are Rust-brained. Typedef. Yep. All right. Yeah. You know it. Like grammar-wise, it works as okay. Logically, it isn't. Got it. Yeah. I know this part works right here. I know this part works. I know if I copy paste this, it's just going to straight up put that as a file. Yep. Config.ini. Yep, exactly. rmconfig. All right, there we go. SAQ3000 config. That'll do the trick for you. You need to type the code later, and after then that type EOF, so it would save exactly this way. Other way would fail. Cat EOF. And then EOF. End of file. To SAQ, right? SAQ 3000-3000. Oh, that didn't work. Do we have to type EOF? LS. Hold on. We'll get it here. Oh. Oh. By AS. Hey, okay. So we're kind of getting it. Yes, I'm familiar with the EOF strategy, or you can call it whatever you want. Right? It could be whatever you want. So you could say something like this. We call it SAQ. Right? Can you do SAQ like that? Like that? SAQ, right? And that will be the same thing. It is. Look at that. Isn't that neat? Isn't that neat? It doesn't have to be end of file. It could be SAQ. There you go. The more you guys know, the more you know. It's been 10 years since I heard someone say storage class. Thank you, Neva. Thank you. Do you know anything about Flipper Zeros? Oh, right. The hardware device that you can use to interact with various radio frequency thingies. A bit. All this to create a file. Why just use Torch? I know, right? Fractal Cow? Exactly. Hey, Quantify Quantum. Good to see you. Cat file text EOF. All right, we'll do that. Cat file text. Yeah, see, that doesn't do anything. SAQ3000, I just typed it in. None do nothing. It does not do anything. Unless your chat message is being manipulated. Oh, it is. Oh, it is. So SAQ3000, I see. I'm seeing it now. You write it wrong. I'm here. I'll show you. Look at what you wrote. See, I'm reading. See what you wrote. And that's what I was seeing. I didn't realize that your symbols were being stripped. Your symbols were being stripped. You're writing it wrong. I'm writing it the way that I saw you write it. Isn't this crazy? Yep. So your chat message, the symbols were being stripped. So I understand. I think what you mean. Here, I think I can do it what you're doing. All right. So I think what you're saying is this, like that, right? I think this is what you're talking about right here, right? That's what I assume you're saying. So you press this and then you say, hello, SAQ 3000. And then you press enter, and you press enter again. You keep pressing enter until you type EOF. Then you press enter, or just kidding, EOF. Actually, wait, did it? E of file. End of file. Well, it's not working now. I just noticed real-time subtitles. Oh yeah, there's real-time subtitles. Isn't that crazy? I was showing wrong. I know it was showing wrong. So how do we do this? Is it there? RMAS. All right. Okay. So cat file.txt. I forgot how to do it. We did it a little bit just earlier. Cat file, then type the data, and then afterwards type EOF at the end. All right. We'll try it one more time. So, see if we can get to work. Cat file.text EOF, like that. Oh, wait, I'm doing it wrong. Like this. File.txt. There we go. Then we say SAQ 3000, press enter, and then we say EOF. There we go. And we got a nice little bash tutorial there from SAQ 3000. Thank you. Yep, there we go. A neat little, without having to open up any text editor of any kind. Use a little bit of a symbols there. A little bit of a symbols. Oh, Steven, can you reply to my previous message? Yes. What'd you say? Quantified quantum. What'd you say? 1 second. I got to pull up the history. Where are you at? Steven, I need someone to remake pseudo utility with me in C or Rust. Would be a fun project. Ooh, it should be Rust, right? It should be Rust. And it worked? It worked. Thank you, SAQ 3000. Yeah, it definitely worked. It worked. I thought I knew about computers and just started watching videos about coding. Now feel like you're in a whole new world. Keep going. Don't stop. Just keep going. Keep going, and it will be amazing. It'll be amazing. As a quantified quantum, I saw your message. Hey, Click and Flicks. I just saw your message over there. Hey, how's it going? Good to see you, Click and Flicks. Let's see if I miss any other messages. Let's see here. Yeah. So, I'm trying to catch up on some of the chat messages, you guys. It's called Here Docs. Yeah, I was noticing all the Here Docs. You can see it right here on the screen, so you can see the Here Doc right there. See, I don't know if you guys can see my cursor on the screen. It says Here Docs. It says Here Docs. Quantified quantum. That sounds like a fun project. Pseudo, you say. So, I'm trying to think of how that would work. It would be based on like user permissions. So you'd need like a file that's dedicated to user permissions. And then you'd have a super user. Pseudo Rust. Yeah, I know, right? Pseudo RS. You got it. You think it's smart to start with C, or go to Rust? Start with Rust first. I'm happy to spot with Python. So, 199. Hey, Kristen, thank you for subscribing. Welcome on in. Good to have you here. Happy to have you here. On this channel, we do software engineering, coding, all from scratch for the most part, without the help of AIs, to keep our thoughts fresh. Here docs were a big deal in Perl. I remember Perl. I liked Perl. I used a lot of Perl. 199. I do like Python as a good starter language. It's simple, and you get some of the basics of flow control and loops, variable assignments, without having to worry about common syntax patterns. Python is very clean. Then going to C, if you want some lower level capabilities. Rust, the same, right? It's a low level, powerful, compiled, performant language. So, sorry, let me rewrite that. Should I start with C, then move to Rust? Oh, well, they're different. Or start with Rust. They're very different. Today, C, here's the deal. I would start with Rust because Rust is more challenging when you're converting from another language. Like me, it took me a long time to really understand what Rust was doing because I am used to languages like C and JavaScript and Python and, Ruby, PHP. I'm used to those other empirical languages. Rust has its own sort of style. It's different. It stands out from the other languages. And it's extra. So if you intend to ever learn Rust or C, I would start with Rust first. If that's the plan. If you want low level, C first. Yep, that's a good idea. If you don't care, Rust is first is fine. But don't touch unsafe. Yes, never use the unsafe, right? Because it's unsafe. It's unsafe. I think if you learn C, all the others are easy to shift to. It is true, except for Rust is its own sort of thing. Rust is just a little bit different. It's just a smidgen different, you guys. It's just a smidgen different. Okay. So let me double check here. Struct person. All right, so we added structs. We got structs here. rm struct. Get add. Get status. Rm file. Get add. To be honest, Rust came to you naturally. The only thing that makes me clueless is async Rust. It's a whole other. Yeah, it is. It's a whole other. Steven, Rust is not empirical. Rust has some functional capabilities and async capabilities. So it is got some empirical and some functional. It does have a little bit of functional. It allows you to do Lambda-like things. You can do it. It took a while to get there, but they added it in. You love unsafe Rust? You love you some unsafe Rust. You've used it a few places for memory management libs. It's the only way to do it. You have to use unsafe. What's the color theme for your code editor background? It's called Groovebox, you guys. It's called Groovebox. All right. Groovebox color theme. Yep, here we go. Groovebox color theme. And I use it in the Ghosty terminal and in Vim. So I use Groovebox Ghosty terminal, Groovebox for Vim. There you go. There you go. Called Groovebox. I see. Nice. All right. So let's see where we're at here. Oh, so we do got to get going. We're over time. It was a lot of fun spending time with you guys today. Let me commit everything really quick. Get status. Commit-am. Added structs. 1 second though. We also added typedefs into our structs. Okay, there we go. All right. Okay. Structs and typedef. All right. Push to main. There we go. Have you used Objective-C? I've used Objective-C. What is G Objective-C? G Objective. I don't know what a G Objective is. I don't know what that is. A lot of the functional methods have unwrap, unsafe, and similar inside the abstraction. Oh. I kind of hate empirical code because you can't do it optimally without unsafe. Well, you can do closures, right? In Rust. Neva, you're familiar with Haskell, so you can do lexical scoping with closures in Rust, right? I'm pretty sure you can. I was pretty sure. Without doing any with like legit safe Rust lexical closures and scoping. Google it. G Objective-C is just like object-oriented programming in C. Okay, let's check it out. Let's check it out real quick. G object. Wait, yeah, G object in C. G object. Okay, what do we got? Taking a look here. The glib object system, or G object, is a free software library providing a portable object system and transparent cross-language interoperability. G object is designed for use with both directly in C programs to provide object-oriented C-based APIs through bindings in other languages and provide transparent cross-language interoperability. Oh, that is kind of neat. I've never had to use it, but it is neat. And it is neat. Like an example in Rust, a split then chars on string faster than indexing. Oh. I did a lot of G-object code. You did? You used GNOME Developer. All right. Doing a loop in C style, I would have bounds checks that are potentially not removed. Oh, okay. Hey, Kevin McAllister, good to see you. Hey, I caught the live, but it's super late here. Yeah, it's super late here. We're, well, I mean in the day. I got to get going because I've got to take care of some other things. It was a lot of fun hanging out with everyone. It was good to see you. Good to see you as well. And tomorrow we'll be back on more C basics. So we did cover a lot of ground. We actually covered quite a bit of ground. Function pointers, which is not necessarily a basic. Strings by reference, structs, and typedef. We did pretty good. Function names are long. Oh, are they manual, vtable, or unions? Cheers, yeah. Thank you guys for hanging out. It was great to see everyone. We'll be back tomorrow. And we'll work more on these. So we'll do unions, which you could do with structs, macros, some statics. Thank you for the likes, you guys. Thank you, Neva. Thank you, Savon. Thank you, Kevin McAllister. Pretty cool stuff. Would you be uploading them on YouTube? Yes, exactly. Yep, we'll be uploading. Neva and everyone else. Hey, Pook. Pauk. How do you say your name? Pauk. Hey, how's it going? Good to see ya. Hey, I had learned GObject because of GTK. Ooh, GTK and Rust. GTK RS. The more you guys know. All right. See you, Steven. Thank you, everyone, for stopping by. We'll be back tomorrow, and we'll be doing more C basics. We'll be doing more C basics. See you, everyone. Bye. Thanks for hanging out. Happy New Year. Happy New Year to you, too. Huge. Happy New Year. All right. Printf high. Yeah, exactly. Printf high. Got to get the prints in there. Bye, Steven. It's still 20 minutes in my clock. I know, right? Exactly. Yeah. We're over time. We're over time. Thank you, guys. Thank you for the likes. Appreciate it. See you tomorrow.